So we are going to look at more nomenclature, and this time I'm going to speak and elaborate on alkenes and alkynes. But first, just let's look at it. Hydrocarbons are made from carbon and hydrogen only, and this here we already looked at alkanes, which are saturated. They have generic formula of CN, H twice as much 2N plus 2, and they were just saturated single bonds. Now today we are going to look at alkenes. So once you have the suffix of "in", that means there is a double bond. This is a double bond, and then you will have two less hydrogens. So CN, H twice as much 2N. And finally we are going to look at alkynes, which is when you have triple bond, and that's the maximum covalent bonds you can have. And then it becomes CN, H2N minus 2. You come highly unsaturated and you have less hydrogens. So first let's look at three examples that their prefixes are the same. We have ethane, we have ethene, and ethyne. Now every time you have ane as last name, it should be saturated. So eth stands for 2 carbon, so it's 2 carbons, and then you have twice as much plus 2, C2H6. If you draw this structure, carbon always has 4 bonds. So the first carbon has 3 hydrogens, the second one has also 3 hydrogen. It's CH3 bonded to CH3. So this we looked at extensively. It's saturated and they are all single bonded. So saturated means they are single bonded. Now today we are going to look at double bond. If I give you ethene, now what you should do, if you have the same structure as ethane, remove 2 hydrogens. So 2 hydrogens should go away, and then you can have the structure that makes sense in terms of Lewis dot structure. So it's a carbon with a double bond between them and single bonded 2 hydrogens. So this is what ethene is, and if you want to write the structure, it's simply CH2 bonded to CH2. So then from now on, we should realize there is a double bond between carbons in this case. Now, if we give you ethyne, then what I did is I took my molecule of ethene and I removed 2 more hydrogens, because you cannot have so many bonds for carbon. Carbon cannot have more than 4 bonds. So this is sufficient for this side, and then the other side, same thing. So it's a triple bond between carbons, and then you have 2 single bonded 2 hydrogens. And that's what ethyne is all about. Now let's look at a little bit more nomenclature. What I'm saying in the next slide is the location of double and triple bond, they dictate your nomenclature. Which one is carbon 1? So I'm giving you an identical molecule. There's 2 possibilities. You can go left to right, and then if you do left to right, 1, 2, 3, 4, 5, 6. But if you do it in the reverse, it's 1, 2, 3, 4. So you choose the carbon which is the closest to double bond. So this is a wrong structure and this is correct. Now we have to be able to name it. So the name has to tell me the location of double bond. And that's why the last name is, well, you have 6 carbons, so it's a hex. And it's a double bond, so it's a ene. Now the location of double bond is 2, so it's 2-hexene or hex 2-ene, whichever you prefer. They are both accepted. And if you want the structure is CH3, CH, CH, CH2, CH2, CH3. Pay attention to this. This is why I can locate the double bond immediately. So the double bond is here, because you have to appreciate carbon having 4 bonds only. So this is a H, and then I continue with CH2, CH2, and I end with CH3. So this is 2-hexene. To have a little bit more examples, you could also have branch on a double bond on alkene. Then again, to number them, I go to double bond and I say this is my carbon 1, carbon 2, 3, 4, 5, 6. And I also spelled out the structure here. Now what would you name it? There is a branch which is a methyl on the 3rd carbon, and the location is 2 the double bond is on 2, so it's a hex 2-ene again, but I have a methyl, so I can call it 3-methyl hex 2-ene, and that's good nomenclature. Or you could call it 3-methyl 2-hexene. Either way works. Now I'm moving the methyl to this carbon, so then again I'm number this 1, 2, 3, 4, not the other side, and this time the branch has moved to carbon 4, so simply this one is 4-methyl hex 2-ene. There's a dash here. Now to have one or two example of alkynes, they have the same mentality or same rule as alkenes. So if you have an alkyne like this, then I know I'm going to number this carbon 1 because it's closest to triple bond 2, 3, 4, 5, 6. The structure is spelled out like this. If you see C and a C, then you should notice the triple bond is right here. And then you continue with CH3 and you go forward with the remainder of the molecule. Now how should I name it? Same as before, this is hex 2, and then your ending is YNE, hex 2-ine or 2-hexine. Now you could have a branch. If you notice, I cannot have the branch on the carbon 2 or carbon 3. I can have it on the 4th one. So what I'm going to say, this is a 4-methyl. The branch is a methyl, it's on carbon 4, and then the remainder of the name is as before, hex 2-wine. We will look at other structures in the next videos.